Yes.
My name is Geoffrey Rockwell. Of course, thank the organizers of this, Joseph, the Vice Chancellor, Peter University, the Digital-Humanities Lab that have organized this, and also Augustine Farinola, who helped connect me with this. And today, what I'm going to do, just to give you a sense, is I've got a little bit of a lecture, which is a bit of a sort of history of the digital humanities with a focus on text analysis. And then I'm going to show Voyant, which is a project that I've been working on for a long time. And uh, in between, I'm going to actually stop and maybe take some questions, and also at the end, hopefully take some questions from there. So, without further ado, I'm going to start. Um, so in 1949, Father Roberto Buzza, who was an Italian who had from the Society of Jesus, he had gotten interested in Thomas Aquinas. He had written his PhD thesis in philosophy on the notions of presence in Thomas Aquinas. And one of the things he had discovered was that none of the concordances for Thomas Aquinas concorded the words that he actually needed to study, the prepositions like in, which or near or on top of and stuff like that. So he he decided it was time to start a project, or he had a vision in the late 40s of a project to do a complete lemmatized concordance of all the works of Thomas Aquinas. And it should be mentioned that, of course, this was Thomas Aquinas was important to the Catholic Church as it was trying to respond in this time to sort of advances of science, the World War II, and so on like that. So this was a project that was important not just to Father Buzza, but to the Catholic Church as a whole. So anyway, he ran into trouble almost immediately because he realized that the corpus, the collection of Thomas Aquinas's works was so large. There's approximately 10.6 million words. Thomas Aquinas was extremely verbose, and it was just not going to be something that he could do in a lifetime reasonably unless he could take advantage of the new information technology that was beginning to appear and be used at the turn of the century there. So in 1949, he managed to cobble together some funds, and he got support from a family in the town in Italy that he was from, Galearte, and he managed to visit the U.S. and visit a number of different locations where they were using information technology to manage mostly sort of library tasks and stuff like that. But in he met Thomas Watson, the head of IBM. And the story, and this is sort of a founding story, and of course, like all founding stories, we should be suspicious of stories like this. But the story that is told and retold, Father Buzza had told it himself, and it shows up in all sorts of histories of digital humanities and so on like that, is that when Father Buzza asked IBM if they would support his project by lending some of their punch card technology, Thomas Watson's reaction was that he thought that that the project was simply too complex and wouldn't couldn't be actually done with the technology that they had at that time. And that's when, as the story goes, Father Buzza challenged Thomas Watson, and you can see this picture in the Father Buzza is in the in the upper left, and Thomas Watson is there, a sort of famous picture with that sort of logo. It's not even a logo, but that sort of the think word above his head. But one of the things that Thomas Watson also believed was that as a company, they should try to do things that nobody tried to do before. They should try to do the impossible. And so Father Buzza challenged him. He said, "You say this is impossible, but shouldn't we at least try?" And he managed to convince IBM to support this project. Um, Talking parenthetically, we also know that the very powerful bishop, a Catholic bishop of New York, was behind the project, and there was probably a lot of a lot of political support from the Catholic Church in New York State behind this project. So I don't think it was simply a matter of Father Buza's challenge that led to IBM supporting this. There were also other components to it. But anyway, IBM did agree to use to make available their punch card technology to the Index Thomisticus project, which in some ways is one of the most ambitious, largest, complicated electronic text projects in the history of humankind. I want to mention Paul Tasman. So it wasn't only technology that IBM made available. They actually assigned an IBM engineer, Paul Tasman, who worked for decades on this. This is really his project. The Index Thomisticus, the print version, which you see behind Father Buza, it's something like 70 volumes. It's so enormous. Was completed in about 1980. A website, a CD-ROM was made available in the 1990s, and a website finally became available in 2005. So this is like a 50-year or more project. So I just want to step back and remind you what a concordance is, because this was a concording project. Concordances go back to the 13th century. They're related to a whole set of different types of what we might call um, interpretive tools, which allowed people who were studying the Bible or people who were lecturing about the Bible, they allowed them to quickly find passages that concorded, that agreed, that had the same keyword in it. So a concordance is, if you go to your library or buy a concordance now, it's a book that has all the important words, content words in alphabetical order, and then for each one of those words, it has typically one line of context of where the word appears. So you can quickly, by scanning those lines of context, you can see what that text has to say about that particular concept or word. So if you're giving a lecture or studying friendship in the Bible, you look up friendship in the concordance, and you can see in one place all of these lines, what today we would call a keyword in context. You can see all these lines, and I put up on the upper left is a example of a very well-known and widely used English concordance of the Bible. And on the right is one of the first printed concordances in English of the Bible. And I should say, by the way, that the concordance really grew out of the interpretation of the Bible. The other thing to say about the concordance is the concordance, if you think about it, there's a series of hermeneutical assumptions built into the concordance, and this is something that we in the digital humanities need to unpack. If I'm right that the concordance and the building of concordances is in some ways the birth of the discipline of the digital humanities, then we need to understand what intellectual assumptions, what hermeneutical assumptions are built into it. And if you think about it, one of the assumptions that's built into concording is the idea that all the different passages in a text that have the same word or concept agree, that in some sense there's consistency in the authorship, in the author's ideas. So if you're looking at all the different places where friendship is discussed, and if you're then using that to build an argument about how the Bible discusses friendship, you're assuming that it's a consistent view. And of course, that isn't always true, but nonetheless, it's a it's a sort of hermeneutical assumption. We should also notice some of the technologies at play here. The the first concordances and the types of indices that were used even before the concordances benefited from the idea of alphabetical order, which today seems fundamental and obvious, but it was the earlier works often organized, earlier tools for interpreting the Bible were often not organized alphabetically, but were organized more by different concepts or by some sort of teleological organization, something like that. The idea of organizing it alphabetically, where allows somebody to actually look up a word without having to know the organization of the text. They can sort of scroll through it and so on like that. And I don't know about you guys, but I still remember as a kid learning to use a dictionary, learning about alphabetical order, which of course was based on my knowing the alphabet and so on. So there's my little quick sort of reminder about concording. And we can think of concording if we think of concording as a type of reading tool or interpret a tool for interpreting text, we can see a sort of history of leading up to and then a history of concording and text analysis in the digital humanities. So 13th century, we have the first concordance to the Vulgate Bible, developed in Paris. Father Booza in 1949 gets the bright idea of, oh my God, concording Thomas Aquinas is going to be an enormous project, much bigger than concording a single text like the Bible. And for that, I'm going to need some of this new information technology that's lying around. And he gets, almost miraculously, he gets significant support from IBM. Uh, and he is the first person to not only use this information technology, but also to start talking about it and showing it to other people. So right there, you see, he's showing it to other people, and other projects begin to adopt some of the same techniques and stuff like that. But then it begins to evolve. So in the 1970s, we begin to see batch concording tools like the Oxford Concordance Program or OCP. We see that instead of Father Booza's project was a custom project. It was, the technology they developed was only for the Index Thomisticus, though they actually used it on some other texts, but it was customized to the particular project. But in Oxford in the 70s, they begin to get the idea of, well, what if we built a generic concording tool that anyone could use? And, they could write us, we could send them the tapes, because back then they were the way data was exchanged. They didn't have the internet or CD-ROMs or anything like that. Send them the tapes. If they had a good relationship with their local university mainframe, the software could be installed, and then they could do their own concording on different texts. And so we get this idea of we want to have sort of shared software that different people can use, but it's all batch concording. And I'll return to this. In the 80s, late 80s, and actually starting earlier in the 80s, we begin to get the idea of interactive concording, where you don't simply, and I'll talk more about that. In the 1990s, we see text mining, visualization tools, and of course, what's happening right now is in some ways tools are being gazumped or being replaced entirely with a new paradigm of AI development, where each person develops their own tools using something like Claude Code. So we're almost back to the 1940s and having custom code to do exactly what you want, that isn't shared with anyone else. But now you don't need an enormous team for it. So there's my quick little sort of overview. Now I'm going to sort of pass back over this and talk a little bit more about these different moments here. I'm just going to check the chat to see if there are questions.
No
No,
questions yet. We're just doing management.
that's good. Am I, can you hear me okay and everything?
Yes, everything is going well online, and I think they're streaming it to the audience in the hall too.
Excellent. Thank you. So, in some ways, the problems that Father Booza tackled and what makes his project, to my mind, really one of the first true digital humanities projects is that he had to tackle two problems in parallel. One problem was how to represent the evidence that he wanted to study, in this case, a text. And the other problem was how to use technology to process that evidence in ways that could answer the types of questions that he was asking. So, if we think of the humanities as the disciplines that study human expression, he needed to figure out how to represent human expression in a fashion that it could be managed and processed by a computer. And then he needed to figure out how to use the computer to ask questions which were interesting to humanists. Now, the other thing to note is that in some ways, especially in the 1940s, uh, and I think this is true even today, text had a privileged position in the humanities. Now, obviously, the humanities deal with other types of evidence than text. You know, art history deals with paintings and sculpture. Our colleagues in drama deal with performance. Our colleagues in music deal with sound and music. So there are multiple media that are important. But at that time, in the mid 19, in the late 1940s and 1950s, computers were barely able to handle numbers and were just able to handle a certain amount of text. And Father Buza actually had the interesting problem, which now we sort of forget about, the problem of how to handle a large text. The computing systems of that time could handle things like names. If you had a database, a personnel database or something like that, you could have somebody's name on a punch card and something like that. But nobody had thought about the idea that we might take 10 million words, entire books, articles, long sentences, and try to figure out how to break them down into something that can be represented on a computer. And in particular, the technology of the time was the punch card. And the punch card is interesting, first of all, because it's a material technology, a material way of storing data. And what you're seeing here, this picture here, is actually a picture that I took of one of the punch cards from the Index Thomisticus project. I went to the archive in Milan, the Buza archive in Milan, and Marco Passarotti, who sort of, um, he's not really in charge of it, but he was a student of Buza, and he supports it. He got me in and showed me this card and a bunch of other cards. So what you're seeing is an actual card from the Buza project, and if you look up, it's actually a single word, closet. But then there's various other types of information about this. But returning to the punch card was a liminal data technology. What do I mean by liminal? It was a technology that goes back to the late 19th century and predates computers as we know them. The first punch cards, in fact, go back to the Jacquard loom and were used in a completely analog mechanical process, were used to control looms. Charles Babbage understood the value of punch cards, and in his analytical engine, I believe he imagined using punch cards to enter data and also to get data back out. And by the time we had the first census tracking machines in the late 19th century, these were using punch cards, where each punch card would represent one person in a census or groups of people and stuff like that. So it was a technology that predates the computer, but it was still used to rigorously encode data. The other thing that's interesting about this technology is that you can, by punching the card, you can enter data, but you can also write on it. And in the Buza project, they actually had areas where the scholars would write over the card. So you had both the encoded data that was machine readable and human readable annotations and stuff like that, which were used in some ways for the management of the process. So, stepping back again, Buza has two problems. And he solves, in some ways, by solving these two problems, he figures out how to move humanity's inquiry, how to make information technology useful to humanities inquiry. His first problem is how to represent a text, and his second problem is how to process those representations in a way that actually saves time and is useful. And what you're seeing here, it's badly reproduced because it came off a macrofiche. But this is from a paper from by Father Booza and Paul Tasman, the IBM engineer, from 1957, in which they described how they went about turning, if you will, books, Thomas Aquinas's books, into punch cards, and then managing those punch cards with punch card technology of the time. And I should say parenthetically, the first decade or so of the Buza project, they didn't actually use computers at all. They were using electromechanical sorters, the sort of punch card technology that was used in the well, more advanced, but that was being used in the first half of the 20th century, which depended on essentially electromechanical processes, but not actual digital computation. And what you can see here, and this is an illustration from that 1957 paper. And unfortunately, I haven't been able to find an original of the 57 paper. And so what you get when you search it and get it through the databases is you get something that was probably first microfiched, and that's why it looks so terrible. But what you see in the upper left-hand corner is that a scholar would basically segment the text, would go through whatever Aquinas book they were dealing, and would come up with phrases, would sort of identify the phrases, and these phrases had to be something that was short enough to fit on an IBM punch card. So the scholar would mark the phrases. Those would be entered by a punch card operator into and would be punched onto a phrase card. Then the phrase card could be automatically sorted to pull out the individual words and create word cards. So now we're getting the automation where word by word is being created, then those can be sorted and managed into form cards. So that's where lemmatization starts happening. And then we get entry cards, and those cards are then used to actually produce the final concordance and eventually the 70 volumes of this massive concordance. I should say that this process is not entirely mechanical. So what you're looking at here is a detail of a 1952 flowchart. When I was at the Buza archive, miraculously, some Italian engineer, sort of showed up with bags of stuff from the Buza project that he had had sort of in their basement or something like that. And one of the things he had was this flow chart developed by Paul Tasman in 1952 that describes the process that they followed to actually sort of punch the cards, do different things. And what you see right here is an intermediate process of scholar writes entry word list. So it was scholars who would decide which words would fit under which lemmas, under which forms. So it was a hybrid process, semi-automated and semi-human scholarly sort of decisions that were done. So we have this sort of magical moment in there of manual lemmatization. One of the things to be said about the Buza project at its peak in the 1960s, it was a factory. They had something like 70 employees. I mean, I would be hard pressed to find another digital humanities project that has that many people and lasts that long. And it needs to be said that it was organized along very gendered lines. The men were scholars, and young women were hired and trained to be IBM punch card operators. And here you see Livia Canestraro, who was interviewed by Julian Neon and Marco Passarotti. They've got a great book in which they talk to some of the people who had worked on this project. But you see her, she's punching in one of the cards. And of course, you see all these men standing around, and actually, it looks like there's a child on the right hand side. But you see these men standing around doing nothing and looking at looking at the punch card operation that's going on there. This is probably a photograph of a demonstration. But we have, my point is that we have a large, complicated project that is segmented into different tasks. Buza is constantly raising funds, and constantly showing his technology and his process to other people. And so when people grumble about the fact that Father Buza is taken as the beginning of the digital humanities, and there's good arguments why other people were doing interesting stuff at the same time or even before. But the thing about Buza is that he was showing that technology to all sorts of people. Paul Tasman was introducing their advances to IBM. IBM was then taking this and building on what they did, especially Loon's idea of the quick sort of came out of the Buza project. So now I'm going to start jumping ahead. One of the first, so that was a custom project, very large, complicated. They had a whole factory, lots of people. Um, One of the things that happened with the Buza project was that actually the young women who were trained and worked on the project then went out and became punch card operators for IBM customers in Italy. So it was actually sort of job training, if you will, that benefited IBM because they had this complicated project that trained all these people and benefited the young women and of course the Buza project. But anyway, jumping ahead to the 1960s, one of the first projects to, in some sense, publish a concording tool was the Prora project, led by Robert Glickman at the University of Toronto. And he sort of, his first conference presentation on the project, I think, was from 1963, 65. And they published the manual of the Prora manual is published in 1965, 66 at the University of Toronto Press. And you see here a quote from that manual. And you also see here a flow chart sort of showing, again, the sort of condensed version of how this project would work. I'm going to just read this quote here. The philosophy behind all the programs, because Prora was actually a set of programs, is that intervention by the scholar should be limited to decision making in the scholar's own field of competency, literature, linguistics, not computer science or technology, and that complex pre-editing and coding of texts should be avoided, and that secretarial assistance should be rendered by a competent typist who has taken a short course on key punching. So you see Robert Glickman, and I've actually met Robert Glickman. He passed away recently, but you can see that in some ways he is trying to rethink or emphasize the division of labor. And in this, you see a period in which the idea that the humanists would actually concern themselves either with key punching, data entry, data representation, or with the technology, he is discouraged. He's trying to still sort of maintain a separation between the humanities and computing, something that in some ways I disagree with, but I still liked Robert Glickman quite a lot, and he and I got along fairly well. You can see this flowchart. If you look closely at the top, we have the literary text. We have various specifications. We have a scholar who has to sort of, again, mark up the text to some extent, figure out the desired characters, the key punch conventions, and so on like that. And then all of this goes to a key punch operator who enters the punch cards. Then those get processed in various ways and eventually produce a concordance. And I should say that this, in some ways, is one of the first projects, along with OCP, that is being published and the code is being shared. So people are beginning to, it wasn't just at the University of Toronto, it was being also shared with other people. One of the things that's interesting about Prora, one of the reasons I like it, is that Glickman was thinking about the output. So at this time, we're at a period in which really the way the humanists and the technology sort of interoperated, the interface was still in some ways paper. You started with the original books that you were concording. They would be entered into punch card. They would be processed. The punch cards would come out the other end, and actually, what would probably come out is a printout, and that printout would be the concordance. But when you went to interpret the text, when you, as the humanist, were interpreting the text, you weren't using the computer at all. You were back to the printout. You were back to a concordance. All that really changed is the automation of the human process of concording. When people were doing it in the 19th century, you would have, much like when they were doing dictionaries and stuff like that, you would have teams of people who were just manually doing the concording, going, taking a word, going through the entire text and finding all the places where it was, and then, entering a card or something like that. So we're automating the process of making the concordance, but we're not actually assisting with the interpretation. And that's why I call this the sort of period of batch concordancers. And most of the tools that came out at this time ran on mainframes. The OCP later was made available as micro OCP, and I actually picked up a manual for micro OCP, and it's sort of fun to look at that. OCP is the Oxford Concording Program, which was one of the more popular ones. But you had electronic text in some fashion or another was the input, and you got a printout, which was the output, and then you would use traditional analog processes from there. So there's batch concording. The next step was when people began to go, well, why do we have to wait for the printout to come out? What if we could use the computer and actually start asking questions interactively of the electronic text? And one of the people that first built a system where you could do this and thought about how to do interactive concording was John B. Smith, who was sort of trained both today we would call him a computer scientist. In fact, he ended up in a computer science department, but he did his PhD under an English professor. So it was Sally Sedlow. And so he was a sort of hybrid. And he began to think about how to build tools that could be interacted with. And in particular, he built a very cool tool and he published about it. No, the tool doesn't really survive because it was a mainframe tool, but it's called ARAS, and for archive retrieval and analysis system. And what it allowed you to do, it ran on it ran on an operating system which was interactive, the CMS or Conversational Monitor System. And this was an operating system for the mainframes, which allowed individuals at a terminal to act as if they own the whole mainframe, when in fact the mainframe was probably doing sort of time sharing. There might be multiple people on terminals, but you could sit there and type commands and get back results on the screen. And so John B. Smith developed ARAS so that you could enter queries. And what you see in the upper left is he has a query here, concordance for the linear category Firecat without values. And the category Firecat is a category of a bunch of words that have to do with fire. And then you see the different words and flaming, fire, fire, and you see the different you see a concordance here. But he's entering it interactively, and he's building these categories interactively. And one of the things John B. Smith realized that, well, if we're doing this sort of interactive thing, we can begin to build visualization. So you can see the distribution of the word fire over your text. And he, in many ways, has been an inspiration to all sorts of projects downstream, even though I don't think ARAS was used much. But just the idea of, oh my God, we don't have to wait for the printout. We don't have to wait for this whole stack of punch cards to be processed and come back a week later and get the printout. We can just start interacting directly with the computer. And that leads to a project that I was not part of, but I was working next door to it, so to speak, which was TACT, or Text Analysis and Concording Tool. This was developed by John Bradley, again at the University of Toronto. You're probably going to notice that I am privileging Canadian projects, and that's partly because I went to the University of Toronto and I'm still in Canada. But I think it also has to do with the fact that it's so cold here that we spend our days indoors. In fact, it's snowing outside right now. We've nothing better to do than to think up interesting computing projects while other people south of us are enjoying the good weather and out hiking and so on like that. Anyway, TACT ran on IBM PCs. It was well documented. The Modern Languages Association actually produced a book about using TACT, and it was developed so that and you could just write and send in a couple bucks, and you get some floppy disk with the program. You get the documentation. It was a very powerful program and allowed you to do all sorts of concording and text analysis things. And it was released at a crucial moment. In 1989 was the first time we had the joint ACH LLC conference. It was the first truly international conference because until then, the field of digital humanities had been to some extent divided regionally. And I should say, by the way, that it was even back then, it was primarily Anglophone and global North countries. But the ACH was a sort of American Canadian association. The ALLC was a European association, the Association of Literary and Linguistic Computing, and ACH was Association of Computing the Humanities. And they actually had slightly different names then, but the idea was that instead of having separate conferences, they should begin to have a joint conference together. uh, that would initially, the idea was that it would go back and forth between North America and Europe. And then eventually it changed its name just to straight DH. Instead of the joint ACH LLC conference, it became DH. And of course, that conference has now gone international. And I believe it's going to be coming to Cape Town, so South Africa, in this summer is Seoul. Next one is Maynooth, and then so 3 years from now, or 3 summers from now. So it's been moving around the world. So it's the beginning of internationalism. But the conference in Toronto in 1989 was still one of the biggest ones that I've ever seen. They had a software fair that was enormous. I was actually at the software fair showing off some HyperCard stacks that I had built, and people like Northrop Frye talked. Ted Nelson showed up and talked about this cool hypertext thing, Xanadu, that he said was going to be available any day. And of course, it never came out, but that's a different story. So the software got a lot of was released at a moment of coming together the field between different regional societies and a sort of internationalization. It also, the software ran on an IBM PC, and a lot of people, at least in the global north, could now begin to afford IBM PCs. You'll remember the PC came out in 1981. It was affordable. It was becoming popular. And with TACT, you could begin to do it. You could begin doing the sort of text analysis that John B. Smith had imagined on a mainframe, but very difficult to implement. You could now do. A single person could type away in a text editor or somehow, create electronic text and then run it through TACT and begin to interact with it. And I should say that John Bradley, I've worked closely with John Bradley. And John Bradley was very inspired, even though this ran on the IBM. Think in 1989, the Mac had come out. He had been looking at graphical user interfaces and actually tried to sort of emulate a graphical user interface on an MS-DOS machine. So this, I think, was really a turning point in the sort of democratization of text analysis. You could now do it on your own personal, and I stress personal computer. um, the lone humanist scholar could sort of continue working alone. So where do we go from there? John Bradley and I collaborated. We took the TACT code, and the two of us. I was actually working for him at that time at the University of Toronto up until about 1994, from whatever, sort of late 80s to early 90s. The two of us were working together, and during our lunchtime, we'd start sort of talking about things. We saw the web, which started, the very first connections in 1989. But it's really 1995 when the web takes off, and we basically adapted TACT to build an online system. And what you can see here is a web page where you could enter a TACT web query, so you could type in what your query was, how long a context you want, and then you got an output. It was basically the TACT output, but we were just piping it through a server and putting it inside a web page. And then we began to get a little bit more ambitious because we got interested in visualization. We began to play around with what you could call text mining techniques, and in particular, correspondence analysis. And we began to play around with more advanced text mining, correspondence analysis techniques. So that was sort of the mid 1990s. I believe we gave one of the first papers on visualization at one of the ACH ALLC conferences, I think in Hungary in 94, 96, something like that. Which leads me up to getting closer to today and the Voyant project, which I'm going to, in a moment, I'm going to talk a little bit about this project, then I'm going to pause, take some questions, and then I'm going to show you Voyant. So all of you have put up with this lecture. You can soon you'll get to actually see software and see how some of this stuff works. So uh, the Voyant project, in many ways, came out of the Tapor project, which I'm going to be talking about on Friday, 2 days from now. Stefan Sinclair and I began to work together closely, and we actually began to think about the process, how humanists collaborate and how we collaborate with technologists and computer scientists, and the sort of, in some ways, if you will, the dialogue between the humanities scholar and the technology programmer, if you will. And we developed a sort of version of agile pair programming where we would sit down for a day. We'd come up with a project. We would, they were fairly modest projects. We'd go off, grab some texts, and then we would try to use whatever tools were at hand, and then we would build tools as we needed and see if we could complete the project within a day. We never actually succeeded completing the day, but we could usually get far enough in that we knew the shape of the project. And this turned into a combination of Voyant as a tool and the book Hermeneutica as a, if you will, philosophical reflection on humanities practices and technology and how we can do computer interpretation, assisted interpretation in the humanities. So the book and the tool sort of go hand in hand. And I say that partly, of course, to promote Hermeneutica, which was published in 2016 by MIT Press. But you can see here we're committed to a very different division of labor, more of a collaboration than the humanities idea of the lone scholar, which goes back to Descartes and sort of, isolation and working alone minimizes error, or uh, Glickman's idea of the separation between the scholar and the key punch and the computer programmer. We're now imagining a coming together of people. Stefan Sinclair was a truly talented programmer. He also had a PhD in linguistics, and I had a background in philosophy. Sort of a coming together of people who are thinking both about the technology and about the interpretation at the same time. And so, on that note, I am going to stop and take a few questions. Can I actually stop? Yes. I'm going to take a few questions and then I'm going to switch to Voyant and actually sort of show you Voyant. There we are. So, we've got a question here. I'm wondering where IBM is now, given the role that they played in the foundational days of technology in the humanities. Well, IBM is, just as a company, sort of in the 40s, 50s, 60s, right up into the 70s and 80s, IBM dominated computing, at least in North America. They were extremely, they dominated the mainframe business. They missed the microcomputer business, the personal computer business. So the first, Apple stole a sort of stole a march on them with the Apple II. But then in 1981, when they came out with the IBM PC, they managed to sort of again start dominating the personal computer business. But they made whether it's a good or sensible or not sensible decision to outsource the development of the operating system to a little company called Microsoft. And that enabled all these clones. And so IBM's dominance of the personal computing business sort of got much smaller. But at least through the 60s and 70s, into the 80s, IBM was supporting the digital humanities. So, for example, TACT was developed at the University of Toronto, but it was developed with support from the Center for Computing the Humanities. The Center for Computing the Humanities benefited from a $1 million approximately donation of IBM to the University of Toronto to set up this Center for Computing the Humanities. So right up into the 80s, IBM was supporting initiatives around the world. Now they don't do that so much. In fact, I'd be hard pressed to think of a major contribution, but perhaps other people know more about the role of IBM now. I mean, I would say Apple has been more supportive recently, but to some extent, the major companies when I was starting in technology, Apple donated a whole lab of Macintoshes to the University of Toronto. There was a lot more the cost of a personal computer included a lot more profit, and there was a lot more companies were doing a lot more to sort of promote their particular computer and stuff like that. They had bigger margins, they had more money, and were supporting stuff. Nowadays, if you go to Apple or IBM or Microsoft or whatever and ask for a donation for a research project, they don't even have anyone you can talk to. So that's my sense. But they really were foundational, not just for Booza. They were foundational for many American projects that and the University of Toronto intact. They were you'll find certain early books that will actually acknowledge the support of IBM.
Thank you very
Other
much.
questions?
Thank you very much, Professor Rockwell. And so far, right from the beginning of the presentation, Professor Rockwell gave us a good review of the history of the earliest technology in the digital, what we know as digital humanities now. But one of the questions that came to my mind is knowing that most of our participants, lecturers and professors from various universities in African country and particularly from Peter's University, whose interest is to come up with Digital Humanities Center and to also have digital humanity projects. I would like to ask what kind of infrastructures can we start with? What kind of support can we get? Like the case of Father Booza started very small. Which way can we actually begin in these low resource centers where there's no support and other things? And what collaboration can we get to be able to start up in some of these institutions in Nigeria and in Africa in general?
Well, one of the reasons I'm going to show Voyant is I think Voyant gives you a free and open tool which lecturers and students can use to basically do sophisticated digital humanities projects. Um, and it's something that you can run on your own personal computer. In fact, when I demonstrate it in just a moment, I'm actually running it on this computer. You can also, if you have support from a central computing facility that is running a server, and by server, I don't mean some super expensive, fancy thing with GPUs or something like that. I mean something like a fairly powerful Dell under somebody's desk. If you have some sort of server support, you can also run it on a server so that all the students, either in a class, if you have a wired lab, or if you have Wi-Fi and students have access to that, they can all access the same server and be working on Voyant and on electronic text that you put up. So in some ways, Voyant also serves as a publishing tool. Or you can work with us and we'll put your texts up and so on like that. So I think Voyant gives you, somebody once referred to it as the on-ramp to digital humanities. It allows people to get going quickly. You don't have to, you can play with Voyant just on the internet. You can, we have a ton of tools, so you can try all sorts of different forms of analysis and visualization. And then if you're really interested, and I can show this, you can actually move to, we've got a new aspect to Voyant where it's a notebook programming environment where you can almost go in and start programming your own stuff. So it gives you a pathway right on. So that would be my answer. I mean, the more fundamental question of the infrastructure, we're at a moment now. I don't know what you have, but at least in Canada now, every undergraduate and graduate student comes to the university with a laptop. Not always a very powerful one, but they have a laptop, they have access to Wi-Fi on campus. So the days in the 80s and 90s, we were building DH labs. We don't need to build computer labs in quite the same way. When we build computer labs now, we build them to provide tools that the average student with their own laptop can't access. So scanners, digitizers of various forms. There's 3D digitizers that are very relatively cheap now. Digital cameras, servers. So that's what the DH lab becomes. But then if you have Wi-Fi on your campus, then you can turn any classroom into a lab where you can teach something and have students playing around with computing. So does that answer the question? Does that
Yes,
give you?
yes, it does, and I think Peter and I mean the Peter University as well as Joseph will maybe connect with the first like one of the things you said about having a computer which can serve the students, and if the students have the laptop, and Voyant being a major Voyant consortium being a major collaboration framework which is open at this time for centers who want to start up, as well as Voyant tool has been fundamental tool that can really help the student to understand the basis of digital humanities and to be able to come up with projects.